Why does my Windows have hundreds of temporary IPv6 addresses? My ISP enabled IPv6 for me a few weeks ago. Now I noticed that Windows 8.1 gets a lot of temporary IPv6 addresses. Its config has the following output: real addresses are obfuscated. I really have not idea where all these addresses are coming from. My Mac OS X on the same network has no problems with temporary IPv6 addresses. In addition to being a strange issue, I believe the amount of IPv6 addresses is slowing down my network performance on Windows. Does anyone have an idea what is triggering this behavior and how to prevent it? I wouldn't like to disable temporary IPv6 addresses completely if possible.
Does anyone have an idea what is triggering this behavior and how to prevent it? From the link Brian gave you, temporary addresses are generated for public address prefixes that use stateless address auto-configuration. More specifically, each process generates a resource request and the OS delivers. The IPv6 SAR is defined in RFC 2462, but the temporary IPv6 address is because of Windows implementation of RFC 4941. So the question becomes, what process is responsible for initiating an OS request to open a socket that has these privacy extensions? To answer your question, what is triggering this, let's look at hardware and software. OS. Windows manages temporary addresses with parameters defined in Netch Interface IPv6 show privacy. To modify Netch Interface IPv6 set privacy ? To check what they are set to on a Linux machine, you would check the kernel variables in /proc/sys/net. You may find the pertinent values for your distro with sysctl a pattern net /if $6.temp. And alter the desired variable with sysctl wfoo.bar.var equals an LT, new value in GT. It should be similar on your Apple machine. Check man sysctl hardware/os. You did netset PTC IPv6, but it may not be a TCP connection. Do a netstat bes a few minutes from each other and see what diff between the v6 blocks are. While I suppose it could be a hardware issue in that the NIC firmware is failing at handling IPv6, it is more likely to be software OS/process being the trigger. If it is hardware, the software side may not be handling the break in the session gracefully and is unable to resume the connection on the previous IP. So hiding it as a software issue doesn't necessarily preclude a hardware issue. Software/OS system processes and services. For this, view network traffic with this URL to identify the process. Because these addresses, by definition, are temporary, they can remain temporarily after the process ends, so you may not be seeing a current, running process with an open connection in NTV if the socket closes immediately. For this, use Process Explorer, this URL, and difference highlighting, options and GT, difference highlighting duration and GT, 9, and then scroll to New Processes, View and GT, scroll to New Processes. An entire row green/red shows a process created or destroyed, respectively, in the last 9 seconds. Once you identify the process, if it is a browser or any app with plugins, you will have to debug which plugin or website JavaScript could possibly be causing the issue by starting the browser in safe mode and enabling plugin by plugin.
Because IPv6 address identifiers remain static, for security reasons, temporary addresses are used. Temporary addresses are IPv6 interface identifiers that provide a level of anonymity. These addresses can be randomly generated and changed over time. The IPv6 protocol for Windows creates temporary addresses for global address prefixes by default. I do not recommend disabling temporary IPv6 addresses. However, you can disable temporary IPv6 addresses with the following commands and a reboot. In Windows 10 and Server 2016, you can use PowerShell set NetIP6 protocol conflict set limits. To find what process is using the temporary address, check the item with local address column matching your temporary address in next.output. If that fails to find anything, you need to use a tracing tool such as Sysmon. To perform this with Sysmon, create an XML file ip6.xml with following text. Then download Sysmon and install configuration file. This will log IPv6 connections in Windows event log under Applications and Services log/Microsoft/Windows/Sysmon/operational. When monitoring is complete, stop monitoring. If you filter by event ID 3, you will get the network events, with details such as below.
If you want to support PJ Hanna, please consider subscribing.